Hi everyone, my name's Comic Christina and welcome back to Abracadabra. Today is lesson 4, Polymer Magic. So from your Abracadabra kit, you're going to need your Polymer Magic bag. From home, you're going to need a table covering. You're going to need a measuring cup for liquids and some water. And then a special note about today's activity, we are using jelly beads and it is going to take some time to prep. So if you haven't done it already, you're going to want to pull the jelly beads out of your kit and pour them into your 9-ounce cup and then fill that up with water. These will need to set for at least 3 hours before they can be used, ideally the night before, but at least 3 hours before they're ready for our activity. Okay, so go ahead and get everything collected, make sure your jelly beads are ready, and then we can get started. Okay, so before we get started on any activities, let's go over some vocab for today. So it's called Polymer Magic, so we are going to be exploring with all kinds of different polymers today. But what is a polymer? A polymer is a strand of the same kind of molecules that are linked together. Another important word we're going to need to know is absorb. So if something is absorbent, it means that it likes to take things in. So if something is absorbent and a liquid is nearby, it will actually suck up that liquid. So we've talked about these words before, but we'll do a refresher. When we're talking about water and some of the properties that they have, water is adhesive, meaning that it's attracted to other molecules and substances, and it's also cohesive. So that means that the molecules of the water really like to stick together. Another property that we are going to observe is surface tension. So when those water molecules stick together, it actually forms a layer. So we actually saw that in the last activity when we were using the magic sand. When we dropped the droplets of water on top of the magic sand, it actually formed little balls of water. And the reason that they did not break up and kind of fall apart was because of that surface tension. We're also going to be talking about air pressure. So air pressure is actually the force that the air around us puts on us, and it puts that force in all different directions, including upward. Okay, so before we get started today, we are going to be using a lot of different materials, and we want to make observations in science, but we want to do that in a safe way. So we can use our senses, but in a safe way. So you can observe things with your eyes by looking at them. If it is safe to touch, you can use your sense of touch to make those observations. You can hear things with your ears. If you want to smell something, you can do that, but you want to do it in a safe way. It's not safe to just stick your nose directly in something. You might breathe it in, and we don't want to do that. So you're going to do something called wafting. So you're going to use your hand to bring up those smells and scents to your nose rather than sticking your nose directly in them. And as far as tasting goes, we never taste anything in science unless we are told it is safe to do so, and we will not be tasting anything in any of our activities today. Okay, so for the first lesson activity, you're going to need your 3 Dixie cups from your kit. You're going to need your bag that's labeled the sodium polyacrylate, and you're going to need your plastic spoon. From home, you're going to want to make sure that your table is completely covered, and you're going to need some water. So go ahead and collect everything and then we can get started. All right, before we get started on our disappearing water trick, I'm going to do a demonstration for you. So I have my 3 cups here, my 3 Dixie cups, and I have some water. What I'm going to do is I'm going to pour some water into one of the cups, and then I'm going to mix them up. I want you guys to follow with your eyes very closely which cup I put the water in. And then when I stop mixing them, you're going to help me figure out which cup has the water in it. And we're going to see if you're right. My objective is to trick you. So let's see if I can do it. So I'm going to add some water to my very first cup. Set that to the side. Okay, so the water is in this cup. Now I'm going to start mixing them. See if you can follow along, and then we can figure out which cup the water's in. Okay, ready, go. Okay, any guesses which cup the water's in? If you guess this cup, let's see, let's find out. Okay, so if you guessed that cup, you were right. Okay, I'm gonna do it again, but this time I'm gonna go a little bit faster, so make sure you're paying close attention. I'm gonna see if I can fool you this time. Let's go. Okay, this cup, or this cup? Let's find out. Do you think it's this cup? All right, if you thought it was that cup, good job, you were right. All right, I'm gonna do this one last time, but I'm gonna go really fast this time. So I'm gonna see how well you're paying attention, and I'm gonna really try to trick you this time. Okay, so just to refresh your memory, the water is in this cup. I'm gonna start mixing. All right, is it in this cup? Let's see. No, not in that one. What about this cup? Not in that one either. So what about this cup? Must be in this one, right? All right, do you see anything in this cup? What about compared to this cup? Do they look any different? Okay, so there actually is something in this cup. It was the water. So before I started the video, I added 1 teaspoon of our sodium polyacrylate to that cup. It was the last cup that I added any water to. And what the sodium polyacrylate did is it is a polymer. So like we talked about, it's those molecules that are linked together, and it is super absorbent. So when we added our water, it actually absorbed all of the water in our cup to change it to more of like a gel. It's like a solid gel in there. And so that is why I'm able to tip it over without anything spilling out. So this is a really cool trick. You actually have enough materials to do this a few times. So you can kind of play with this. You can even do it for like your friends or family and see if you are able to trick them and show them the magic disappearing water trick. All right, so now we're going to talk about the science behind how the sodium polyacrylate works. So a polymer is a large molecule made up of many smaller units called monomers, which are then joined together. So some polymers are made up of millions of monomers. Super absorbent polymers, like the ones we just used, expand when they come in contact with water because water is drawn into them and held by the molecules of the polymer. So they act like giant sponges. So this sodium polyacrylate is actually found in diapers, and they help give diapers that really absorbent kind of quality about them. So that's kind of a really neat example of how science is all around you and used in real life. All right, now that we know exactly how diapers work and what makes them super absorbent, we're going to do an activity, an experiment, to figure out how much water a diaper can actually hold. So from your kit, you're going to need your diaper, your clear 16-ounce cup. From home, you're going to need a liquid measuring cup and some water. So I'm going to go ahead and fill up my 16-ounce cup, and we are going to measure out a half cup at a time to see how much water our diaper can hold. So first, I'm going to go ahead and open up my diaper so that I'm making sure I'm pouring the water on the absorbent part in the middle. Okay, perfect. All right, so a half cup at a time. So let me turn this around. All right, here's my first half cup. So let's see if it holds it all. I'm gonna pour it pretty slowly on there. Okay, my diaper absorbed all of that half cup of water. And diapers have this protective like coating film on the bottom, so if you feel on the bottom, it's not wet. It stays inside the absorbent material, and it has like a layer in there to kind of block the water or liquid from coming through. All right, so let's try it again. Do you think that the diaper is going to hold another half cup of water? Let's find out. All right, gonna slowly pour there. All across the absorbent part, and then let's see. It's pretty cool because I can actually see the diaper soaking up the liquid. All right, it held that all, and now it's getting pretty heavy. Let's see if it'll hold another. I'm almost out of my cup of water. All right, let's see. All right, my diaper actually did absorb most of that. So we're at a cup and a half of water at this point. I mean, it's really, they talk about saggy diapers. That's a saggy diaper, but it's still dry underneath. All right, let's see if it'll do another one. What do you think? Can the diaper hold 2 cups of liquid? I think I might be close. I was gonna say maybe I'm close to reaching capacity, but I really don't have a lot of water sitting in there yet. So let's just add 1 more half cup and see what happens. It really did absorb most of that. I think that's my last half cup. Let's see. Okay, that might be all we're able to do. It is starting to spill out of the diaper. Okay, so somewhere between 1.5 cups and 2 cups is about the limit of my diaper. Did you get the same results? All right, now we're going to experiment with air pressure and surface tension with our mysterious water suspension experiment. So you're going to need the plastic bowl from your kit, the specimen jar with the lid, a rubber band, a piece of mesh, and your 4 index cards. And then you're also going to make sure your surface is still covered for this one, and you're going to need some water. Okay, so the first thing we're going to do is we're going to fill our specimen jar about 3/4 full of water. Okay, next we're going to take our piece of mesh, and we're going to use our rubber band to seal the mesh around the mouth of our specimen jar. I want to make sure it's nice and tight. I'm going to put it on once, make sure it's nice and smooth. Oops. There we go. And I am actually going to wrap mine around twice just to make sure it's on nice and tight. Go. I'm going to pull the mesh down around like this to make sure it's nicely kind of fit around the mouth of my specimen jar. Okay, you don't really need the lid, so you can put that to the side. You're going to put your bowl of water here, and then we're going to take one of our index cards, and we're going to place this over the top of our jar. So it should look like this. Should be nicely around the top. And then the card's just going to get placed right over top, just like this. So you're going to take your hand and you're going to cover the top, and then we're going to flip it really quickly upside down over our bowl and see what happens. All right, ready, go. And then we're going to take our hand away and we're going to see what happens. Okay, so as you can see, my card is stuck to the jar with the water, and no water is really coming out. So this is actually happening because of air pressure. Right now there is air pressure that is pushing against this card. Even though it's upside down, like we talked about, air pressure moves in all directions, even upward. So the air pressure right now is strong enough to hold this card in place. All right, so keeping it over the bowl, we're actually going to remove the card. We're going to slide it out quickly. Okay, so our mesh had holes in it, right? But is any water coming out? No. So this is happening because of surface tension and because of cohesion and adhesion. So the water molecules are actually, they're attracted to each other and they're attracted to other surfaces. So they're kind of stuck together and then they're forming almost like a film with something called surface tension, which is why the water is not moving and why it's still stuck, even though there's holes there. It's forming like a film in between those tiny little holes in the mesh. But if we move the water sideways or we touch it, we can break that surface tension and then the water will come pouring out. So let's see. So what's really cool about this is I'm breaking it, so it's coming out, but then it's forming back together again if I touch it. Glad I have the bowl here. Okay, now let's see what happens if I turn it sideways. Okay, it all came out at once. So that was pretty neat, and that's a really good demonstration of just how much force air pressure can have to actually hold all that water in with just our postcard, or index card rather, and then just how strong surface tension can be. It can actually hold water in place, even upside down through holes. So that was really neat. All right, so now we're going to be using our jelly marbles in our vanishing jelly marble experiment. So you're gonna need your clear 16-ounce cup from some of the other activities. You are going to need some extra water. You're going to need your cup with your jelly marbles, and then you're also going to need your piece of paper that has your Science Explorers logo on it. All right, so what's interesting is I know that I added these jelly marbles to my cup. But if you look at the cup, can you see the jelly marbles? If they've been sitting in there for at least 3 hours and have finished doing their absorbing, they should pretty much be invisible. I can't see mine at all. Can you see yours? But if I stick my hands in there, I can feel them, so I know they're there. All right, so grab one and pull it out and hold it in your hands, and we're gonna make some observations. So I can see that it's really grown in size, especially compared to how it started, and it's still holding its spherical shape. So fun fact about these jelly marbles is that they're actually also a polymer, and they are super absorbent. So just like our sodium polyacrylate, these are super absorbers in terms of polymers too. And they can actually gain up to 300 times their weight with how much they can absorb and still keep their shape. So that's pretty cool. All right, so now we're going to carefully add all of our water into our 16-ounce cup, but we're going to keep our jelly marbles in the 9-ounce cup. So I'm just gonna put my fingers over there like that to pour the water in. So weird, it's like they magically appear. Okay, so now we're going to do a little experiment dealing with refraction. Okay, here in front of me, I have our Science Explorers logo on our sheet of paper. And then I have my cup of our jelly marbles that we emptied the water out of. Okay, so first, we're going to put the cup of jelly marbles with the water emptied out over top of the logo and see what that looks like. Can you see the logo? Not really, the view is pretty obstructed. So now we're going to try to add the water back into the cup and see what happens. So pour it carefully back into your cup of jelly marbles. And as you can see, the logo kind of magically appears. Now, the reason for that is because the actual index of refraction is the same with the water and the jelly marbles. So once we add the water, you can kind of see right through the jelly marbles. Without the water, that refraction is kind of a little bit bent around the marbles. But when we add the water, you can actually, the refraction is then through the marbles, so you can see the logo. So that's pretty neat. All right, now it's time for our magic bag activity. So from your kit, you're going to need the other plastic bowl. We provided 2 of the Ziploc baggies for you, just in case there are any mishaps with one. We have an extra. You're gonna need your 3 bamboo skewers. You should do this over a covered area, and you do need water from home. So go ahead and collect your materials, and then we can get started. All right, to start our magic bag activity, make sure that your water is in something that's easy to pour, or you can even do this over the sink. So you're just gonna fill up one of your little baggies with water. Make sure you leave enough room to kind of seal it up. If you fill it to the very top, it's gonna be very hard to seal. See, I actually added just a little bit too much, but that's what this bowl is here for. Okay, there, perfect. All right, so my bag is completely full here. You can see it's sealed up nice and tight. All right, so now you're gonna hold the baggie over top of your bowl, just in case. You're gonna grab one of your skewers, and you want to be careful because, as you can see, these are pretty pointy here at the top. And what we're gonna do is you're going to carefully poke into the bag on one side, and you're going to actually poke the skewer all the way through the bag to the other side. Now this bag is filled with water, and we have it hanging over a bowl just in case. So do you think there's gonna be any spills? Let's find out. Be sure to, when you're putting the skewer in, not to put your hand on the other side where you can poke it. Okay, so my skewer is all the way through the bag, and as you can see, no water is spilling. Now, if you wiggle it a little bit, you might notice some spillage. But let's see if we can add another skewer and get the same result. So I'm gonna see if I can do this with all 3. And you can add them in at different angles. So I'm actually gonna try to put this in like that. See? A couple little leaks there, but nothing too bad. And then I'm gonna try to do it from this side and see what happens. Okay, so no leaks. That's pretty neat. All right, before you take the skewers out, let's talk about the science behind this and why it's happening. So the bag is actually made of polymers. And like we talked about, polymers have linked chains, but there's actually lots of little holes already in the polymers. So what happens is when we stick the skewers through, the polymers move around to make room for our skewers, but then they kind of wrap around the skewer and hold it tight so that way the water can't escape. So that's kind of just a demonstration of how polymers work and kind of how they can close around a space and how all the little holes are and how we can work with that. So you can take the skewers out. Do not do that over the bowl though, that'll be pretty messy. When you're ready to take them out, do it over a sink because the water is going to run out. You can just kind of observe what happens when that process kind of occurs. So if you only used your one bag, you can do this again with another bag. You can reuse your skewers and try to put them in different ways. And if you want to try it again, you can even do this with Ziploc baggies at home. It doesn't have to be the specific shape. So that was pretty cool. I thought for sure more water was going to come out, but that it didn't. It's not really making a mess at all. All right, guys, that's all for our Polymer Magic lesson. I hope that you learned all about polymers and now have a much better understanding of the scientific concepts behind that. Make sure to join me next time for our paper puzzles lesson. See ya!